mental notes? Yeah, let's try. What's the antiderivative of 3t minus 2?
3 halves t squared plus 3t.
We're going to evaluate that from 1 to x, right? So I get the derivative of 3 over 2x squared minus 2x. Minus 3 over 2t squared plus, or sorry, x squared. I don't know. 1. Minus 3 over 2 times 1 squared minus plus 2. Not that any of that matters. Okay. Why do I say that doesn't matter? So when I do the derivative, those are constants. What's the derivative of constant? 0. So I end up getting, what's the derivative here?
3x minus 2.
I feel like I could have done that a little faster. I feel like maybe that was a waste of my time. Maybe. You see it yet? What did I get? Why would I get the exact same thing that I had in the integral? Now let's try the next one. So good notice I got 3t minus 2. My answer ended up being 3x minus 2. So it's the same as the original. So I'm going to explore the next one. I already know the antiderivative, right? I can cheat a little. Except this time I'm going from 1 to x squared. So I get the derivative of 3 over 2x squared squared. Right. Minus 2 times x squared. Minus 3 over 2 plus 1. Okay. Then I'm going to take the derivative of that. What do I do when I take the derivative of this, and what do I have to do to take the derivative of that? Okay, I either have to multiply it out. I'm going to go ahead and just do a chain rule for fun. So if I did do a chain rule for fun, would you agree that I would get 3 times x squared good so far? Times 2x minus 2 times 2x. For whatever reason, we would do it that way. But everyone agree? The chain rule drew the inside. Just for fun, I'm going to rewrite this as 2x times 3 parentheses x squared minus. Isn't it that fun? So let's make the last one. We made a conclusion that the derivative and the integral just canceled out, right? Well, this time it Actually, those should be T's right now. No, they should be X. Sorry. Sorry. I've already plugged in. Right? Everyone agree? No?
Where'd you get 3 over 2?
Antiderivative. From the very first one. These are the same function.
They are?
3t minus 2. So I'm using an antiderivative. I quit writing it all the time. But it's the same
I was wondering where you're pulling it out from.
It's just red. So, but it's right there. This one. That antiderivative the whole time. Except this time I'm evaluating it from x to 1
Yeah.
instead. So I just plug in the 1 first and then the x. Does that make sense? I'm going to do the derivative of that. What happens to all of the constants? They go away. Do you agree I get negative 3x minus 2? Why do you think I got negative 3x minus 2? If they were backwards, so I get opposite of what I would normally get. So, we learned some things. See if you can help me write the shortcut. In general, if I have the derivative of an integral from a constant, I'm going to call the constant a, to u, where u is a function of x. So pretend u is a function of x. Remember, I'm doing the derivative with respect to x. Of f of t dt. What would that answer be? Is that going to save you a lot of time? Okay. This is the fundamental theorem of calculus. Revisit it. This is the first part of the fundamental theorem that you learned. We just didn't use it much. We just talked a little bit about it being area relating to the derivative, but we were a little shady on that still. But now we know that they are truly inverse operations. And so I can save some time if I have the derivative of the integral. But I do have to be careful. If that function up there is not just an x, I do have to take into account the change. So this is a nice little shortcut for you. Any questions on that? This is the one I prefer you use, the one with the u up there. The one from the textbook has an x up there. Be careful about that x being there because you have to be careful about the table. But if f of t is continuous on a degree, remember to integrate, you have to have continuous on it. Then, if t of x is defined as an integral from some constant to x, then the derivative in t is f of x. Again, be a little bit careful about that. If that is anything other than just x, you have to do a change. So that last thing you wrote down was pretty important. I would probably circle the last thing you wrote. Even though this is the official fundamental theorem, the other one gives you a little extension to it with that you can write. There will be questions like this on the AP exam, and we get really excited when they show up. You can, the x prime would be 1 since it's just x. So that's where I would also write down this. Kind of an extension to you. Miss King's edition. Some textbooks write that, but this one didn't. I don't think. This slideshow might be from an old textbook. Yours might write it if you do it. I get a lot of these little boxes. We have textbooks online, so I get a lot of these boxes copy pasted out of textbooks. Okay, example number 1. 2-second question, isn't it? What's the answer? 2x minus 3. That's it. Now, could you do it the long way? You would waste a lot of time. You could, but it would waste a lot of time. Everyone see how I got that? Now, a lot of calculus teachers don't make you do that bell ringer before they teach this. And the question always comes up, why did the t change to an x? Do you know why the t changed to an x? Because you actually integrated from 7 to x and then differentiated, and that changed the letter. Does that make sense? Okay, let's look at the next one. What do we have to be careful about on the next one? C's on the bottom. So what's the only thing we have to do different? A negative. Since the C's on the bottom instead of on the top, it's backwards to the zero. So I just do negative sign of Z over Z. There's that zero as a letter. And you saw from the bell ringer why that happens. If it's behind it, then it's got the negative in front. Okay, any questions about that one?
It's capital F on the same as X.
It is. Good question. She asks if capital F prime is the same as little f. Yes. So the yes. Probably. Okay, the next one. What do I do when there is something other than just an x?
Oh, you gotta do chain rule.
Okay, so next derivative, and they use f, right? And that should be x, but there's a typo there. That derivative would be cosine of x squared times 2x. Now, is that a lot faster than anti-differentiating, plugging it in, going back and doing the derivative? Save you a lot of time. Chain rule, chain rule, chain rule. Be careful about the chain rule. Any questions about that? Okay, so AP practice.
Great.
Yeah.
Whoa, where'd it go? C-A-P.
Yeah, we'll get there. Before that, we're going to do this one. So you know almost everything you can know for this chapter. We only have one more lesson. So that means we can kind of start looking at some basic problems. So this says let h of x equal the integral from 0 to x of f of t dt, where the graph of f of t is shown in figure. At what point will h of x have the greatest value? Well, what is h of x? The area, right? So when will the area be the greatest from 0 to x? B? Is that what you said? I agree. Why after B would the area decrease? It's negative, so we're going to take away area. And then this little area is not enough to compensate for all of this area we lost. So B. Do y'all remember when we were doing distance velocity, position, acceleration problems? And do you remember when we had to find maximum position? And you always kind of, on the absolute maximum, you always kind of had a guess a little bit. You could probably figure out this area thing is going to be important for that when we go back and look at velocity, position, acceleration again. We will revisit. Okay. Let h of x equal the integral from 0 to x of f of t dt. Here the graph of f of t is shown below. At what point will h of x reach its minimum value? C, why? Okay. Now, I want to go back and look at both of these in a completely different context. You were thinking area. Would you agree f of t is the derivative of h of x? And how do you find a minimum from the derivative? Okay, get your AP packs out. We're going to work up here. We're going to start working. We're going to work numbers 1, 2, and 3 if we have time. Your homework is this, so go ahead and write that down. 4 through 8 on the packet, and page 306, 2 through 18 even. We will grade those on Friday, but we have, tomorrow we have a new lesson, so,
Sounds like you're trying to do this.
no.
They're all happy, and then they all explode. They're all full of themselves. So,
Tomorrow you will have more homework.
that is
I do. Okay, so I got that down. 306, 2 through 18 even. I want you to do that tonight, definitely. AP packet, try and do these questions. You get a little. Wait. Okay, let's look at. Okay, let's look at. Let's look at number 1 on the AP packet. Everyone else has an AP packet in their hands? Okay. This is a real AP problem, right? That's what all these AP problems are. Real open response problems off of the AP exam. The graph of a differentiable function f on the closed interval 1 to 7 is shown above. Let h of x equal the integral from 1 to x of f of t dt for 1 to 7. Find h of 1. Why is it 0? And an integral from 1 to 1, right? This is the integral from 1 to 1 of f of t dt. I have no idea what f is, but I know if I'm going from 1 to 1. That integral is 0. Any questions about that? Find h prime of 4. What is h prime of 4 going to equal? F of 4, right? Everyone agree? H prime of 4 is the same as f of 4. Which is? Real AP problems. Isn't that exciting? 108 is perfect. 108 out of 108. What? We will take an A/B test, so you get kind of the fill the test in after we have 2 more chapters, and then we'll take an A/B test. So you can kind of fill out what an A/B test looks like. We will take a bunch of these tests in March, April. As soon as we finish all the group. We'll see how many we fit in. This is my first time speaking about this. My goal is 4. That's what I did last AP. So we'll see. I don't know if 1 8. The one it may end up being. We'll see when we finish Y from 1 to 3 and 6 to 7. The slope is positive, the slope of f prime. Okay. We figured it out. So from 1 to 3 and 6 to 7. Have we finished the question? It does. And I'm sure y'all remember how much you love that word.
No. You are mistaken.
Justice. Yeah.
Justice.
Okay, so justify. What would our justification be? If I'm going to talk about concavity, I need to talk about the second derivative, right? So I need to say H double prime, which is equal to f prime of x, right? H double prime of x, which is equal to f prime of x. And what would I say about that?
I mean, you can say anything about that.
It's positive. Is that enough justification?
Yeah.
Okay, it's letting the reader know that I'm thinking about the second derivative of h, but I get that from the first derivative of x. That makes sense? Find the value of x at which h has its minimum on the closed interval 1 to 7. A minimum on a closed interval, would you agree that's an absolute minimum? It asks the minimum on a closed interval. It didn't say relative minimum, so I don't want the actual minimum value of h on that interval. Well, what are my options? What could it be? Could be 1, could be 5, and it could be 7. Everyone agree? Okay. Why? Where am I getting 1, 5, and 7? The endpoints and the critical points, right? Everyone agree? So, I want the value of the minimum, right? Now, someone said the answer was 1. Tell me why. It's before it's even, what's the value at 1? You actually know that. It's 0. Then I'm going to add all of this area. And then I'm going to subtract this little bit of area. You all agree that 0 or 1 is the minimum value? So let's answer the question first. We'll justify later. Don't forget to answer the question, even if it's justified. Sometimes we'll work really hard on justification, forget to answer the question. So the value of x, which we have a minimum value, x equals 1. Justify. Well, we've never been able to justify this well before. You remember we did some problems like this in the fall, and you were always like, it increased more than it decreased. Y'all remember you having a hard time putting that into words? Now we can say h of 1 is less than both, well, h of 5 we don't even have to consider because it's a relative maximum, right? Is less than h of 7. Because why?
Because it increased growth and decreased.
There's more area. There's more positive area than negative area on the integral from 1 to 7. No. Okay? There's more positive area than negative area on the integral from 1 to 7. So I'm accumulating more area after 1 than I was before. Any questions? Okay. As far as difficulty of AP problems go, how'd that one feel? Not too bad, right? Those are commonly missed, but if you understand the relationship between the integral and the derivative, not too bad. That was all 9 points of that problem. I have the year. I don't remember what it is. And let's look at this one. Again, very, very common AP question. Compute g of 4 and g of -2. Now, at first glance, this looks like it can be tough because they don't give us a function. But, what is g of 4? The integral from 1 to 4. Can I find all of those areas?
You could.
Using shapes, right? So g of 4 is, in this, so I've got from 1 to 2, I have a trapezoid. 1/2 base 1 plus base 2 times that. Base 1 is 4.
Just put the triangle out of the box.
You can. Times the width, which is 1. Right? Everyone agree? What happens if there's 2 triangles?
Oh, they can't
I
fly.
don't even need to put those down because they're going to cancel out, right? G of 4 is 3. Any questions about that? Make sense? What's a little bit strange about g of -2?
Oh, you're going backwards.
So I need to make sure I make my answer negative. Other than that, I'm going to find an area from 1 to -2, but I do have to make it negative.
Boom.
No. So g of -2, and it probably didn't get put even because I was in response to that show that I was doing the integral from 1 to -2 of f of t. Which would be, that's just a triangle, right?
Yeah.
Base of 3, height of 4.
Boom. When you did in the time that 2 get 6. Alright.
Why negative?
Oh my goodness. Got the table.
Please don't follow the chain rule on any justice.
It's the table.
No, it's not. Okay. Find the instantaneous rate of change. What's another word for that? Because we went backwards. From 1 to -2. See how that's backwards? Normally smaller. -2 and 4, we're going to actually put this red and blue work down as our answer. And you don't have to copy the work, just copy the t of 4 equals 3, t of -2 equals -6. Don't know where you did the work because you'd already done it in the previous problem part. And then you would say x equals 3 is a relative maximum. Just to let the reader know, you checked 3, it's not worth even writing. You can find the area, but